Okay, this is Yudhi here. I'm from ULBI. For this opportunity, I would like to present about the mid-semester assignment for warehouse management from my instructor, Dr. Ernawati, CMILT. Okay, we go to the next slide. So basically in this assignment, we have two case study. The first case study is PT Trustlaw. Basically, they are a warehousing company that store various consumer goods. So basically now they has a project to store 10 types of spare part for one customers, which is company X. They have the warehouse area foreign is 5,000 meters square with a storage system using pallet racks. So the main issues here is over the past 3 months, several operation challenges have been encountered, right? So the challenge itself is self-arrangement doesn't match the frequency of goods retrieval. I mean, it's mixed between fast and slow moving. And then the forklift parts are often blocked by temporary pallets, random storage for the good itself, and some fast-moving goods are placed far from the receiving area. The impact for the business is picking time increased by 35%, and there are job queues and risk of accidents, as well as pickup errors increased by 80%. And the last one is outbound lead times become longer. So this is the information about type of goods stored in the warehouse. So we have GHIJ with the details as seen on the screen. So basically there are 5 rooms required for the warehouse activities. The first one is the receiving room, storage room, sortation room, packaging, and the last one is shipping room. The size of each room, the movement of the goods transported, and the cost can be assumed. So basically, the PT Translog Management is requesting a solution to rearrange the warehouse facility layout and storage system become. The first one is increase the efficiency of picking, packing, and put away operations, reduce the rate of picking and errors, as well as the last one is optimally utilize the warehouse space. Okay, so this is basically my proposal to PT Translog. So basically the problems can be resolved by implementing a structured facility layout and an efficient storage system. The primary recommendation is to adopt a product flow layout combined with an ABC analysis classification system and dedicated storage based on the frequency of the goods movement, whether it's fast or slow moving. Okay. The following are the recommended layout and storage system details. Point A is warehouse layout arrangement. So I will try to implement the ABC analysis for goods classification for the first step. So basically, I'm trying to classify 10 types of goods based on their investment value or movement using ABC analysis. So basically, this will help me to determine the priority of good placement. So we go to the next page. So this is basically the ABC analysis from my perspective. So I'll calculate based on the value. The total value will become the class A because it's like from value wise, it's like 78.43% compared to the other goods, right? And class B, the total value is 16.99, almost 17%. And the rest 5 items, the total value-wise is only 4.58%. So class A, which is item B and E, is high priority, high value, requires close monitoring, and is frequently accessed if assumed to be high frequency, right? I mean the high throughput. Class B is for item H, A, and D, which is the medium priority. And the last one, which is the low priority, is class C, is item J, C, I, F, G. Okay, we go to the next slide. Okay, so this is the warehouse. So I recommend to use a U-shaped warehouse layout for 5,000 meters square using the activity relationship or ERC method to create proximity relationship between warehouses and the unique area facility layout problem method to design the warehouse layout. So this is the ARC analysis. The first room is receiving, storage, sortation, packing, and shipping. So the red one here means very necessary, right? And the yellow one is very important, is very needed. Green one is needed. The blue one, and so on and so forth, as you can see in here, right? So I so far only using 3 colors because it's like relation between receiving and storage is highly related. So that's why I made it become red. Okay, we go to the next slide. So this is basically the layout design. I use the UAFLP method using the DEFLP software. So we split the area become 5, right? Receiving area, I make assumption is need like 500 meters square out of 5,000. Site length 20, minimum site length 20, maximum 25 with aspect ratio 1.25. And then storage area, this one is the biggest one because it's like 3,000 square meters out of 5,000 with minimum site length 50, maximum 60, and then maximum aspect ratio 1.2. The third room is sortation area. I make assumption with 600 meters square with minimum site length 16, maximum 37.5 with maximum aspect ratio 2.34. The fourth one is packaging area, 400 meters square. Minimum site length 20, maximum same 20 with maximum aspect ratio 1. And the last one is shipping area, which I make assumption 500 square meter. Minimum site length 20, maximum 25 with maximum aspect ratio 1.25. And then using the movement 1 to 2, 2 to 3, 3 to 4, 4 to 5, and then 1 to 5. Right, so this is the assumption of the amount, as you can see in here, 50 cost 5,000, 150 cost 15,000, 75 cost 7,500, 200 become 2,000, 20,000, sorry, 75 becomes 7,500. So I use the ELFP software, as you can see here, iteration 500, blah, blah, blah. And this is the result, right? I will go to the next slide. Okay, so basically this is manual. Somehow it's like, is mirroring to the slide. So this is the recommendation. To address the problem of random placement and long distances, I recommend a dedicated storage system based on movement frequency. So this is a storage room number 2. Fast, slow moving, combined with fixed position ranking for each SKU. So if you remember, the one with ABC analysis is item B and E. You see here, B and E is close to room number 4, which is the packaging area, and then it will slowly flowing to shipping area. So this is the inbound, and then number 3 is sortation. So from inbound, we sort and ready to put away, and then we put into the storage room, which is 3,000 meters square. This is the hot item, right? I will put it close to the shipping area, packaging area, and then close to the shipping area number 5. Recommendation number 2 is optimize pallet racking, which is we will use a fixed position racking system. Each item has a fixed location. This is to reduce the picking errors, which currently increased by 18%, and to optimize the rack height for optimal space utilization, which is currently we only have 5,000 meters square. We use the standard selective pallet tracking that is compatible with forklift movements and provide 100% access to every pallet. So in summary, by implementing a U-shaped layout and dedicated storage organized based on ABC analysis and layout, I use to design this based on the relationship chart. So Trustlock can achieve the following management objectives, which is increase time efficiency. Travel distance are drastically reduced by placing fast-moving goods in the strategic zones. Reduce error rates, which is we use a fixed position system to eliminate confusing random storage. Increase space utilization. This is why I recommend to use of structured pallet racks and height to make the maximum warehouse storage capacity become optimized. Okay, now we go to case study number 2, which is PTX is a logistic company. 3PL experienced numerous issues related to stock integrity. This include a high number of damaged and missing product in the warehouse for number 1. Number 2 is low turnover ratio indicates excess stock, resulting in an increase in the number of products nearing their expiration date or near ED and potentially unsellable. So the challenge here is what inventory control strategies or policy should the company implement to address this issue? And I will need to include the references as well. So this is the discussion material or the proposal. So PTX should implement ABC analysis as well, same like the case study number FIFO or FIFO rotation, first in, first out, or first expire, first out rotation, and to conduct regular cycle counts, safety stock optimization, and a warehouse management system to address the damage or missing stock and low turnover issues. So the first challenge is to reduce damage and shrinkage. We need to conduct regular physical inventory checks and like a surprise audit to identify the discrepancies early, combined with strategic product placement and clear labeling to minimize errors during picking and storage. Implement data analytics for real-time tracking to detect patterns in theft, damage, or misplacement, while we need to training the staff on proper handling and using barcode RFID for automated monitoring. Second one is how to improve turnover and expiration control. We will apply the ABC analysis to prioritize high-value or fast-moving SKU for frequent monitoring and control resources efficiently. Adopt the FIFO and FIFO rotation by placing new stock behind the older batches, in ensuring near expired items ship first to cut the waste. Last one is the policy enhancement. We need to set reorder points, safety stock levels, and minimum threshold based on the demand forecast to prevent excess buildup. Flushing slow-moving stock via promotions or redistribution across sites, and integrate WMS or ERP for SKU level turnover tracking and alerts on expirations. Partner with clients for vendor managed inventory to align replenishment with actual needs. So this is basically the proposal, and the last slide from me is the references, as you can see here. So that's my presentation for this mid-semester assignment for warehouse management from Dr. Anna. Thank you so much. This is Yudhi speaking.